Hello everyone, how are you doing? I trust you are all doing great. James from JTS Maths Tutoring here. Today we are going to be looking at another question concerning matrices equality, and we are looking at question 29 under exercise 1.3 in Elementary Linear Algebra application versions 11th edition by Howard Anton and Rorres. Right, let's get started. A matrix B is said to be a square root of a matrix A if B squared is equal to A. So find the two square roots of A. How many different square roots can you find of A? Do you think that every 2 by 2 matrix has at least one square root? Explain your reasoning. All right. So let my B be a 2 by 2 matrix here with the entries A, B, C, D. So B squared is going to A squared plus BC, AB plus BD, AC plus CD, BC plus D squared. So remember, two matrices are said to be corresponding entries are equal. So what this means that into the given 2 by 2 matrix. Right. So the next step is for me to equate the corresponding entries and then solve the result. A plus BC is going to be equal to 2. AB plus BD is going to be equal to 2. AC plus CD is going to be equal to 2. BC. And I can see here that from equation 1 and equation 4, BC is 2 minus D squared. This implies that A squared is going to be equal to D is equal to plus minus D. In 2 and equation 3, I can see that these are symmetric equations in the sense that you can interchange the position of B and C and still come up with the same equations. It's actually going to be equal to C. So if I look at equation 1, instead of having BC, I can have it as B squared right there, right to my equation 4 as well. Right, so using equation 1, A squared plus B squared is going to be equal to 2. But I already know that A squared plus D squared is going to be equal to 2. What? B and C and D as well. So solving for A, I can now solve just for A. That means A squared plus A squared, which is going to give me 2A squared equal to plus minus 1, meaning that A, B, C, D, they are all going to be plus or minus 1. And that is actually going to give me two matrices there. The first with all ones is the entries. Or the second one, it's also a 2 by 2 matrix with minus 1 is all the entries. So those are the two square roots. Only way in which you can actually solve this. But for first year students, would rather go with this algebra route. Once we learn other, about matrices, then we can actually employ the other methods. All right, beautiful. Then they asked us this. I can actually solve this the same way I've done right here in A. But I've just tried to introduce something new, though you have not learned that one yet. But for those who are actually aware with matrices, you can tell that for you to get to the square root of a diagonal matrix, all you simply do is you take the square roots of the entries on the main diagonal. So this is what is going to give us the full. Then the last question was they wanted us to reason whether every 2 by 2 square matrix has got at least one square root. And they want us to explain our reasoning. If we say yes, we should be able to back that one up with a valid reason. If we say no, we should also be able to back it up with a valid reason. So here we are, because remember the definition of a square root. Every square matrix A doesn't have a square matrix B such that B squared is going to be equal to A. Thus, while some matrices do have, consider this new potent matrix below. Perform some algebra, which we have just done in question A there, and observe the outcome. All right, I'll leave you at this point in time to put on your dancing shoes and show me what your mama taught you. Mine is actually calling me to do dishes right now, so I have to go. So till we meet again, I want you to be rest assured at JTS, we are committed to keeping you mathematically informed. Adios, amigas and amigos.